Ladies and gentlemen, it's a great pleasure today to have with us a gentleman who speaks all over the world on the topic that you are about to hear. The discovery in Chihuahua State, not far from here, of a strange skull for which scientific evidence has determined is not entirely human, if at all. It's called the Starchild Skull. And I remember vividly the day in 2007 in Roswell, New Mexico, when I walked in while Lloyd was talking about this at the Roswell UFO Museum, and I was just stunned at the information and the scientific basis that supports this. So we're very honored to have Lloyd and also Ray and Melanie Young, the folks who originally received the Starchild Skull from El Paso, visiting with us today. I guess Ray stepped out from them. Yeah, and I understand there's a replica also that you'll be showing. The skull is kept under heavy security, heavily secured location, undisclosed, for security reasons. So, without further ado, here is Lloyd Pye and the amazing story of the Starchild Skull.
That's one of those few introductions that really isn't an exaggeration. It truly is an amazing story, as you'll hear. Well, can you hear me okay with that? It's a little low, but...
Yeah.
Okay. Oh, yes. Okay. What you're going to hear today is obviously a condensed version of the information that you can find in that ebook right there, Starchild Skull Essentials, that you can get at starchildproject.com. It's well worth the time and the little bit of money that it costs, because it's extremely educational about a process that has gone on for, it'll be 15 years in February. 15 years we've been working on this, gaining information about it, new information, trying to figure out what it is. And once we knew what it was, then the goal became just simply trying to prove it to a level that science will accept. Because I'm sure you all know that in a game like this, they can get the wispiest little bit of evidence and make a claim, discover a little piece of bone and say that this is a new type of human. And it's just absurd the things that they get away with. But when we make the kind of claims that we're making that they're not happy with, they say if you can't prove it up one side, down the other, and this way or that way, then it doesn't count. If you can prove that 80% of it, it's not enough. You have to prove 100% of it. And that's kind of where we are with the Starchild, as you'll see. Okay. It's all right. You can still hear me, right? Okay. Anyway, so that's just a little bit of background about where we stand and what we're going to go over here. Am I doing the wrong? Oh, sorry. Whoops. All right. It's pushing up. It's pushing up. That's good. Yeah, okay. I don't know what we did wrong. What on earth is the Starchild Skull? Is it even from Earth? In 40 years of practice as a reconstructive plastic surgeon, I have never seen anything like it. I doubt if anyone else has either. That's from a quote from Dr. Ted Robinson of Vancouver, British Columbia, a specialist who's worked with us for almost the whole of the 15 years. And he remains as committed and passionate about his research with it. He's had it for almost a year, and he had a number of his colleagues work with it there in Canada. And we have the reports and all on the Starchild Project website, which of course no mainstream scientist pays any attention to. Those who publish the Wikipedia articles about it, they pay no attention to. Only when a critic says something about it in contradiction to what we have, do they listen and do they say, well, that counts and you have to believe the critic? So, because we have a vested interest in whatever we say, therefore is ipso facto wrong. Not true. The Starchild Skull was found in Mexico in about 1930, about 100 miles southwest of Chihuahua. So, as you may have heard already, not far from here at all. It was found in a mine tunnel in the Mexican high desert area around Copper Canyon. And in that mine tunnel was discovered by a young girl who was from El Paso at the time, but her parents had come from a village in that area. And it's a big area. We don't know where, we don't know the exact name of the village. We can't go back there to the same place and recreate anything because we don't know exactly where it was. But it was somewhere in that area. And they went back to the village and brought the kids, and a young girl, teenager at the time, 13, 14, 15, she couldn't remember in later life, but in that range. And she went out basically exploring and found a mine tunnel and went in, and she found lying on the floor of the mine tunnel two skeletons. Well, one skeleton lying on the floor, and then beside it was a mound of dirt, and she noticed what she called a misshapen hand extending from the dirt wrapped around the upper arm bone of the skeleton that was on its back on the ground. Reuben, I'm sorry, can I interrupt you? Yeah, I'm sorry, I'm too loud. Yeah. Lying on the hand was wrapped around the skeleton lying on its back, making a clear indication that there was some kind of a link to what was in the grave. And so because it was in a mine tunnel and there was no compaction of the dirt, she scraped the dirt away to see where the hand went, and she exposed the whole skeleton that she called misshapen. She said it was a misshapen hand and a misshapen skeleton. Total. So she ended up, it's a long story and we don't necessarily have time for it now, but she ended up with the two skulls that had sustained some damage, but she brought those two skulls back to the States and she turned them into souvenirs. She shellacked them, put them in a box, and basically made souvenirs out of them that she kept her whole life for about 60 years until the early 90s when she found out that she was dying. She passed them on to a pair of friends who kept them, the skulls in the box for 5 years, and then they passed them on to Ray and Melanie Young in the latter part of 1998. Ray and Melanie, as Noe said, are here. Stand up and let everybody see you now that you're both here. That's Ray on the left, the guy, and that's Melanie, the one on the right, the girl. Anyway, so when the skulls came into their possession, Melanie had been a neonatal nurse for about a dozen years, and she knew right away that it didn't have any of the hallmarks of the standard human deformity. She knew deformity, and that didn't fit the pattern. It didn't look, number one, didn't look anything like a human skull, and it was too light, and it just in general, it didn't look right. And she felt, more importantly, as a member of MUFON, Ray and Melanie were members of Mutual UFO Network of El Paso, that it looked really like the skull of a gray alien. That it looked like the skull of a gray alien. Oh, I'm sorry, this slide should have been up the whole time. And so as you see, there's a huge difference in the way the Starchild looks versus how a human looks just looking from the front view of it. And so with that in mind, they tried to find out what it was, or if they could find out if it was a deformity, what kind it was. A couple doctors, a couple specialists in El Paso told them not to worry about it. It was just a cradle-boarded hydrocephalic. We'll talk about those terms later. But just a cradle-boarded hydrocephalic. It's a dime a dozen. These things are routine. I heard it myself from, you shouldn't worry about this. There's nothing special about this. Just take it home and forget about it. Get rid of it. Do whatever. But, there's nothing special about this. Not true. This is three views of the Starchild. You see one, a very nice close-up of the eye sockets, and then you see on the right, you see a comparison of half the human face to the left and the Starchild to the right, so you see some of the differentials there. And down at the bottom left, you see a sort of built-in lower face for the Starchild, but entirely too big, just too big to be accurate, but at least to give you a sense of what it might have looked like with a lower face attached to it. Now, despite the first X-ray report, the Starchild is not a child. We called it Starchild because, as you see, when you X-ray that piece of maxilla, and the piece of maxilla is this right here, from the front top to the right, inside that part, you had 3 teeth that were missing and 2 teeth that were there, as you see in the front picture, and the picture on the left. And up at the top, and the little piece of bone that you see there at the top, there were, as you see in the X-ray, 5 crowns of teeth waiting to come down. So the X-ray technician says, well, if you have teeth down and teeth up, it has to be a child of 5 or 6 years old. So we ended up calling it the Starchild, when later we found out that those teeth that were down and visible were much too worn to be the teeth of a child. They had to be the teeth of an adult because they had a lot of wear and tear on the enamel. So it isn't the skull of a child, not just for that reason, for other reasons as well, but it is not a child. Now, we talked about the term cradle-boarded hydrocephalic. That was the standard answer for a long time by the mainstream until I said what I'm going to tell you enough times to make them understand they weren't getting away with it. When a child is cradle-boarded, and it's a very common practice, or was a very common practice in primitive societies of old, the child would be strapped onto a board, as you see there on the left, and in strapping them down, you see that strap at the top, they'd have to put a strap across their heads to hold their head in place. The whole point of it was to put the infant on the mother's back so she could work and do her job and do her stooping and fetching and carrying or whatever. And as she would do that, a baby's head would snap around if it was not held in place, because their head is very big and their neck is very weak at the infant stage. And because an infant's bones are so soft when they're born, they will take almost any shape that you give to them, which is why head binding practices produce unusual shapes of heads. So what happens when you're cradle boarded is just the flat part of the rear of your head flattens out, as you see with the human. This is a standard. The human found with the Starchild was a standard cradle-boarded individual. And what you see is when the head is upright, as it should be, it stops right here at this point right here called the inion. Now all of you just take a moment and reach back in the back of your own heads to right here, and at that point where your neck meets your skull, and you have a knot back there, and that knot is called an inion. Everybody has it, every human, and in fact, chimps, gorillas, monkeys, if you've got a head sitting on a neck, at some point you have something like that. So it should, it can't go further, the board can't go further than the inion because it would tear neck muscles loose. So it just stops, as you see, right there, and it goes up to the top of the crown. So you've got an area about the size of the palm of my hand that's flat. And when I say flat, it's as flat as the board that it's pressed against. It is flat. The Starchild, not so. As you see with it, its flattening goes well beyond the inion area, which is right there, all the way down to the absolute spine almost itself. It goes down to the neck opening. And so its neck is shown to be right there, about half the size of the normal human neck. Its neck is literally a little bit bigger than my wrist, its whole neck. So the Starchild is very radically different right there, but there are many other things that you're going to hear and see that are radically different as well. Now, what you also see that as the Starchild is put, if the human was put on a cradle board, it's sitting there with its face up, breathing nicely, no problems, it's comfortable. If you see if the Starchild is put on the cradle board, its face goes down like this and it's strangled in a very short time. You can't breathe in that position. So it was not cradle boarded. Your sub-average moron could see this and understand what I'm saying. And yet, if you have PhD after your name, you can't see this. This is not clear to you at all. Now, as far as hydrocephalic, that's a term you've probably heard, water on the brain. It's not water on the brain, it's spinal fluid on the brain. And what it is there are valves that allow spinal fluid to come in and valves that allow the spinal fluid to go out. If the valves don't work that allow the spinal fluid to go out, it just builds up and builds up and builds up, and the head blows up like a balloon. That is what hydrocephaly is until the pressure inside kills you. Now, it's fixed now. Now they fix it right after they know that you have it, and they put shunts in there, and it's no problem. But in the old days, it was a death sentence. Your head was just going to grow and grow until your brain was squeezed out of your neck hole and you would die. And that's it. So with the Starchild, as you see, it was not a hydrocephalic because, number one, it's very symmetrical in the way the hydrocephaly doesn't blow things up necessarily, but it is like a balloon. So there are no creases. And if you see the human skull has a nice round shape to it back here, but the Starchild has a crease back here. So you couldn't have it blowing up like a balloon and be creased. It just couldn't be, and you wouldn't have that shape either. It would be pushing out equally in all directions, so you wouldn't get that sharp backside either. You'd get a much rounder look. So the Starchild was not a hydrocephalic. It just simply wasn't. Again, average moron could pick this right up. PhDs, unfortunately, cannot. Now, the new one is, since the cradle boarding and hydrocephaly doesn't work, the new one that they've come up with is progeria, because progeria does do some things that exhibit the Starchild the way the Starchild looks. Number one is that they have larger heads and they have shrunken faces, and their bones are indeed thinner and of course lighter. But progeria is that horrible illness where when a child is born, they become old immediately. They start getting really, really old immediately. So that over the course of about 15 years, if they live that long, they're the equivalent of someone normal 100 years old. So a kid 6, 7, 8 years old is this age 3, you can already see how shriveled up and doddering he is. Because as we get old, our bones do thin out. Our bones do become very, very fragile. They become like, eggshells. They're very fragile. The Starchild does have thin bone, no question of that. But its bone is 2 or 3 times as hard as normal human bone. The Starchild's bone is extremely hard and very different, as we'll see later, from normal human bone. So the Starchild did not suffer from progeria. Whatever else it might be, it didn't have that as an issue. The Starchild had no frontal sinuses. No frontal sinuses at all, no sign of them. As you see in a normal human, these things here that look like kind of like cauliflower, these are frontal sinuses. This is the human. Those are the eye sockets right there. You see with the Starchild, not even a vestige, not even a little nub, they never started to grow in the Starchild. And that's its eye sockets. Now, what are your frontal sinuses for, do you suppose? You are probably under the assumption that it has something to do with healing you when you're sick or you get a cold or something like that, your sinuses get all clogged, or you have allergies or whatever. What they really do, what your sinuses really do, is they provide a resonating mechanism for your voice. They allow your voice to resonate the way my voice is resonating now as I speak to you. If I didn't have any frontal sinuses, my voice would take the timbre of like a robot or something like that. It wouldn't sound good at all. But if we all talked like that, it would, it would be okay. But that's what it does. It gives your voice a resonating capacity. So I want to plant the first seed in your mind that the Starchild maybe didn't talk the way we talk, that it communicated in a different way. Because if it was indeed a gray alien, as we think it was, the skull of a gray alien, it would communicate telepathically, because everybody says that's how they communicate. They don't talk like we talk, but they communicate, but it's brain to brain. And the Starchild seems to have everything it needs to do that. As I said earlier, the Starchild's neck is half the size of the human's. And here you see the outlines of where the neck would be on the human and where the neck would be on the Starchild. Again, about the size of my wrist, maybe a little bit bigger. So you got this whole head, large head, sitting on this tiny spindly pipe stem of the neck. And that neck is sitting directly under the center of gravity of the skull. Not where our neck is. Our neck is like 2/3 back. It's like the back 2/3 of our heads. But the Starchild's is dead under, directly under, on this skinny little neck. How do you suppose that worked? It's balanced perfectly from the rear to the front and side to side on that little tube. And here's why. Because nature endowed it with the ability to balance that big head on that little neck this way. If you take a baseball bat, try it when you get home if you've got one. Take a baseball bat and hold it down at the bottom and put the barrel up like this. If you hold it perfectly balanced, perfectly centered with the barrel straight up, it's pretty light. It isn't really hard to hold. But if you tilt it over 1 degree, 2 degrees, 3 degrees, the more you do, the harder it gets to hold because gravity takes over the barrel. If gravity's pulling the barrel straight down through your hand, it's pretty light. No strain. That's why its neck is redesigned this way. If it's got to have a very small neck and a big head relative to that neck, it has to be perfectly balanced front and back, left and right. We're not. And I would put to you number 2, that it has another point that indicates it doesn't speak because it's not going to have room in there for a voice mechanism like we have, for a voice box, a larynx, and all those things that we have, hyoid bone, and the different things that we have that allow us to speak. Not going to be room in a neck that size. Okay? Probably didn't speak. The zygomatic arches in the Indians. Now, the zygomatic arches are simply the cheekbones, and you see what the humans would have looked like when they're, and one of the human cheekbones is actually there, so we know how it looks. And we see the Starchild's from its base points to its eye sockets where it attaches, and you see that it's a very small and very short and very narrow throw from one to the other, meaning it didn't have cheekbones like we have. It had a very narrow face that just went down, and it didn't have cheekbones to speak up. It had a very narrow face, which again, people say that that's how gray aliens look. They have a very narrow face, and the Starchild has that. Now, as far as the Indians go, you saw that on the human, it's right there, and ours is right here, and then our neck begins, and we see that the Starchild's, look where it is, right down there at the very, very base. So its neck, all this area is missing, and the Starchild has an Indian down here. Tiny, again, more proof of the tiny little neck. But remember I said if you've got a head on the neck, you've got something like an Indian somewhere, and the Starchild does. Chewing muscles and brain design. You can see that the chewing muscles come up through your cheekbone, and we see that with the human one right there, where that's what connects your jaw to your skull. Those muscles that attach here and come down through here, and they attach to your jaw, and hold it. I'm so sorry. Hold it up. When you die, and any skeleton dies, the lower jaw is completely loose. If you lift the skull up, the jaw stays down. There's nothing really holding it up except those muscles. It is not attached to your face. in any way other than those muscles. Now look at the difference in the Starchild. It's about half the volume, which indicates a much smaller lower jaw, which it had. It clearly had that. Now, the brain of a human, this is really interesting. The brain of a human sits here, and you have your cerebellum here, and it sits in the curve of your skull back here, and it's resting in this curve where there are some flanges of bone that hold it. Because your cerebellum is your software, it's your drive. You think with this part up here, but your motor, the thing that runs you, is your cerebellum tucked in back here, about the size of my fist. And that is what runs your breathing, your heartbeat, your manufacture of urine and feces, and all the things that go on 24/7 and never stop even when you're sleeping. That's your cerebellum. It runs you. It is your motor. It is your software. You hurt the cerebellum, that's it. Chinese in some cultures, they execute you with a bullet through that. You're not recovering from that. We all know, Gabby Gifford, you can recover from a bullet through your brain, but you can't take a nail through the back of your cerebellum and survive that. Not a nail. So that thing is well cared for. Your cerebellum is extremely well cared for back there. Again, it's in a cup. And that cup has flanges in it so that over the course of a very long life, the 3 pounds of brain up here pressing down on it will not shove it out the neck hole and kill you. With the Starchild, you got a completely different design. Number one, you have a much bigger brain, and we'll talk about that later, but you have a much bigger brain capacity, volume, and if it has a cerebellum, if indeed it has a cerebellum, it is not protected by sitting in a cup with flanges of bone holding it in place. It is a straight shot. It's like a fat kid going down a slipper slide. Right out the chute, right out the neck hole, and there are no flanges of bone in there to stop it. So that brain should have just pushed its way right through here and right out the neck hole. And it didn't. So the brain guy says, well, you either have a different texture to the brain, or you don't have a cerebellum or a different kind of cerebellum or something, but something is not human, because if that was a human brain in that head, in the Starchild head, it would have come oozing out a long time ago. It wouldn't have made it out of infancy or childhood. Bone thickness and surface texture. All you have to do is look at this and see the difference in the bone thickness. Remember I said that it was thin, the Starchild's bone is much thinner? When you, with the models, when you hold them, you can see that the Starchild is much lighter than the human model. Much lighter in the hand. And those models are stereolithographic copies, and they're exact. You can feel the weight, and you can see and you can compare them. So the reason for the lightness is the Starchild's bone is just much thinner, half or less. And it's much harder to cut. I've cut it a few times and I've watched others cut it, and I can tell you, it is much harder, 2 or 3 times as hard as the human bone. Look at the difference in the thickness. It's a completely different design in the bone. Now, if you look at the surface texture, you see this is the human bone here on the left. You see these little holes here, they're called lacunae. And these lacunae, what they do, they have a really, really important function. You know the story about all the cells of your body change out every 7 years except for your brain, right? Well, this is how it happens with bone. The bone migrates from wherever, let's say a cell migrates here toward that lacuna right there, and it goes in, and it just goes in and it's eaten and it's chewed up and it's dissolved and turned into whatever they turn into. Meanwhile, others of these lacunae are spitting out freshly created bone cells, and it's constantly going on. And over 7 years, all of the bone in your body gets changed out that way. You know, it's a 7-year itch. My body's not your body, and the body wasn't going to like you anymore. You know, 7-year itch, 7 years. It does work like that. Notice the Starchild, though, has none of that. None of that. So if it's a deformity, where did those things you go. How are those things lost in a human deformity? They would not be. If you're a human, you're going to have some sign that you have the capacity to regenerate your bone. The Starchild doesn't have that. These are all things, each one of these are things that a normal science, if they were actually real scientists really dedicated to the truth, they would jump all over any of these to try to find out the truth about it. These are things they don't want to know about. They avoid all they can. Fibers and residue, these are absolutely unique. There are these fibers, as you see, and you can see here's one on the surface of the skull, just showing how they are woven into the matrix of the bone. Here's some here. Here you see a cancellous hole, and you see this coming up here. This is a blow-up of this right here. And these fibers are very, very durable, because when the bone was being cut, the way we discovered them was, as you see, they clung to the edge of the cancellous holes, and they were made visible, and you could see them. And it's like, what's that? Nobody had ever seen it before, because there are no such fibers woven through the bone of any other species, any other bone on Earth that anybody knows about. This is like rebar woven through concrete to make it that much stronger. It makes the bone, it's not all that makes the Starchild bone so much harder. Some of the chemistry is different as well. There's a lot more collagen compressed into the Starchild bone, and collagen is like what makes your teeth hard, a lot of collagen in your tooth enamel. But anyway, so there's that. And then also in the cancellous holes, which are the holes where your marrow goes and moves through, is created and moves through, you have this red residue that is found afterwards. Now, it's automatically easy to think, well, that's just dry blood, right? It's just dry blood. Not so, because blood, as you know, when it oxidizes, turns black. Let blood fall on the street or anywhere and let it stay there, and it'll oxidize black. So if that were actually to be blood, it would be black. But when you die, there are bacteria that absolutely scour all of the cancellous holes in your bones, and they eat every single shred of the blood that's in you. That's what their job is. And so you shouldn't be finding it in anything, or maybe a rare piece now and then, but it'll be black. If you do, it won't be rare. These two things, both the fibers and the residue, are not found in any other species on Earth. Again, if there were scientists out there worthy of the name of scientists, they would have been all over this years ago. We bring this to them and they run the other way. Don't want to know about it. Not what they're in business to do, which is change the world inside out. That's not what they're here for. They're here to keep things the way they are. That is the job of science. You have to understand that. If you sit there wondering, well, gee, this sounds pretty good. Why doesn't science want to know about this? Because those who sit in the power chairs of all branches of science, all aspects you can name, if they have worked their way up and are now sitting in the power chair, they have one job and one job only. Keep things the way they are. Don't allow big change on my watch. After I retire, okay, make all the big change you want, but not on my watch. And each new guy that hits that chair takes up that banner. I will allow change, incremental, small change, to move things forward, but nothing big, no giant steps, not on my watch. And they fight tooth and nail to keep it that way. Okay? Now, facial proportions, widely divergent from humans. This is an image of the Starchild that I particularly like. I think it's the closest, best one that we have. But this is a clay model that was created by a guy named Bill Bruns. And, rats. I'll go back here, sorry. And Bill, in looking at the eye sockets, he made a very human-looking eye. And I said, Bill, you can't do that. The eye socket is so shallow, the human eyeball would sit off like a frog eye. And he said, yeah, you're right, they look terrible, so I cut them in half. And then I put them in there, and then they fit. I said, but, you know, I did kind of cheating, isn't it? He said, well, there's no other way to make it work. And I said, well, what about the neck? That neck looks awful big relative to what it really ought to look like. And he said, yeah, but you know, you got all that weight up on top on that little bitty neck. All it takes is one bump and the whole head will fall off the neck. So I said, okay, well, that makes sense, and let it go. But another friend named Chris Murphy from Canada looked at the proportions of the face, and I really learned something here, and I think you will too, why the Starchild is so different. Did you know that our faces are designed in general in a very unique way? Our eyes sit at the midpoint between our chins and the tops of our heads. Our eyes are in the middle at 50%. The tips of our noses are midway between our eyes and our chins. Our mouths are 25% midway between the tip of our nose and our chin is our mouths. Everything is proportional, and you see that the Starchild's proportions are completely different. The most significant probably is the ears. The Starchild, a human's ears, would be up here. See how your ears go with your eyes. The tops of your ears go right with your eyes as a rule, within a little bit of difference. And the Starchild's ears are like down there. Completely different. And the Starchild's inner ears are twice the size of our inner ears. Twice the size. Now, we talked about the speaking thing, and I want to go back and address that again, because now I want you to think about this. It has no frontal sinuses. It has a very big brain, and when I said that big brain, this is what I want you to take away. The Starchild is a little smaller than average size. It's about the size of an average 12-year-old. And the human with it is the same size, about a 5-foot-tall female. Her brain capacity is 1,200 cubic centimeters. 1,200 cubic centimeters. Just keep that number in mind. As we all sit here in this room, other than the children, our brain capacity is on average about 1,400 cubic centimeters, 200 centimeters more. So it's 1,200, and our average is 1,400. The Starchild is the same size, volume-wise, as the 1,200. It should have a 1,200 cc brain. It's got 1,600 cubic centimeters. 400 more centimeters than it ought to have. So, in talking about how it communicated, it has a very small neck that indicates that it doesn't have a voice mechanism. It lacks frontal sinuses that says that it doesn't have the ability to resonate its voice, and it's got this monster brain in there. To me, those three things strongly indicate that it communicated by telepathy. Telepathy. And that's what people say that gray aliens do. Now, all of these things that we've talked about so far are physical aspects. Physical aspects. And unfortunately, for as interesting and as exciting as they are totally useless in the battle to try to get science to accept the Starchild as what it is, which is non-human. Because why? All you have to do is start pushing them a little bit, and they say, nature can do anything. Whatever you say, there's nothing you can say that I can't say to you, nature can do anything, and I win because I'm right. Nature can do anything, and I'm right because my whole group of people, all of the PhDs out here, have agreed that what we say is right. And when we say nature can do anything, nature can do anything. So one of them said to me one time, he says, I don't care if you stack up 10,000 of these physical differences, it doesn't matter. All I have to do is say nature can do anything, and you lose. I win. Why are you wasting your time? Why are you wasting my time? And the answer is because I'm right and you're wrong. But they win on the strength of numbers. and credentials and qualifications and all of that. I am the moron that we were talking about earlier as far as they're concerned. I'm that moron. All that counts in this game is DNA. DNA. It's the only way we can win against them because it's their tool. We can run them through with their sword. But we have to get the means to do that because it's expensive. And they shut us out from all access to funding. There's no way to get grants to do things that the mainstream doesn't approve of because those who sit on the granting committees are mainstream people themselves. And they're not going to allow money to go out for something like this. We have to come up with the money from private funding. And there's just no other way around it. And that's the rub. That's why I'm talking to you here 15 minutes later. It's convincing a wealthy person to help us. Because you can go in and you can talk to a wealthy person and you can show them all of this and they'll say, well, that's pretty interesting. That's really impressive. I'm going to look into this. And the first thing they do is they go and they call some friend of theirs that they went to college with who's a scientist in some way or other, and they say, look, I just saw this guy say he had an alien, it looked pretty interesting to me, would you take a look at it? No, I'm not going to look at that. That guy says, that's just stupid, that's wrong, that guy's hustling, you don't get involved in that. And it happens every time. They just, whoever they go see, whoever they go talk to, that's the end of it. Their science friends are going to tell them, without even seeing it, without knowing the first thing about it, it's just ipso facto wrong because it's not what they're told to believe. Is that a radio? Oh, there you go. Thank you. Thank you. All right, now we're going to get on to the DNA. So, DNA is the math of biology. What it says is law. All right? If DNA says it, it is. You know how it goes. 50 people can say they saw somebody kill somebody, but if the DNA contradicts all that verbal testimony, that visual testimony, the DNA wins. The DNA puts you in jail and the DNA gets you out of jail. Puts you on death row, gets you off death row. DNA is the math of biology. It's important to understand that. And the great thing about the Starchild is it's got good DNA. It was buried in a mine tunnel, and so its DNA is there and pretty, relatively speaking, easy to get. It's still ancient DNA. It's still very degraded. It is still very contaminated, as all ancient DNA is. But we can work with it. We can work around those problems. We can succeed. Now I'm going to just go over, I'm not going to overwhelm you with this. I'm trying not to in these lectures. I'm not going to overwhelm you, but there's some things, basic things you have to learn to kind of get it in mind why it's important. Okay, so bear with me on this. You've all heard of the double helix ladder of DNA. The ladder or the rungs are what are called nucleotides. And the nucleotides are thymine, adenine, guanine, and cytosine. And they are combined into base pairs, what are called base pairs. Each of those is what's called a base, and they go as pairs, and they're always together. Thymine goes with adenine, and guanine goes with cytosine, always. They can be on one side or the other of the ladder, but those are the ones that always combine together. So basically what you're looking at is two distinct combinations of base pairs. Does that begin to ring a bell with anybody? Computers are 0 and 1. And 0 and 1 is the language of computers. Very, very simple, but it's capable of infinite complexity. Very, very simple. This is the same thing. You have the equivalent, the biological equivalent of a 0 and a 1. Very profound simplicity capable of massive complexity. Biology, math. Get it? DNA is the math of biology. So, with that understood, we go to the NIH. Now, what is the NIH? It's the National Institutes of Health. And what is it? It pays for a lot of the genetic research that's done by the mainstream labs in the world today, in this country today. And what happens is if the NIH gives you the money to do any research into a genome of any species at all, they give you the money and you owe them a copy of the results. That's the deal. And so all of the information goes into a giant database that's maintained at NIH headquarters in Maryland. And so over time, you get millions and billions of what are called comprehensive base pairs, base pair strings, where you can understand and recognize them, and they will be familiar to the machines. The computers have them in there. When our geneticist contacted me in the early part of 2010, and he said, my wife convinced me to read about you and your book and everything, and when I first heard about it, I thought it was hokum, but I read it. You seem like a legitimate guy on an honest quest for information. He said, if you give me a sample of what you have, I will be able to tell you whether it's something interesting or not. I can do it, I have the capacity. And I said, great. Send him a sample, and within a few weeks he contacted me and he says, well, you really have something here. He says, we recovered about 50,000 now out of 3 billion, understand, it's an infinitely small fraction. 50,000 base pairs, sent them into the NIH, and surprisingly, some of them came back, and when I say base pair strings, the top string you see is 265 base pairs long right here, and that one came out as having a corollary, an analog, exactly the same, on Homo sapiens chromosome 1, genomic contig there. They knew where, the computer can show where on that human genome those 265 base pairs fit. And some of these, base pair strings fit on things like rabbits or zebrafish or different things, but all on terrestrial creatures, all part of terrestrial life. About half of the Starchild's base pairs came out that way. But he said, about half of them, like this one, that's 342 base pairs long, came back with no significant similarity found, meaning wasn't in the database. Yeah, wow, wasn't in the database. So he said, if this happened in, 1 or 2 or 3 or 4 of these strings, I could excuse that. But it's about half of them. And there's no way to excuse that. You probably have something here, and I'll be willing to work with you if you want to pursue it and find out what you have. And we've been doing that for the last 3 years. Now over that time, by hook and by crook and eking along, we've recovered several hundred million base pairs, several hundred million. But only about 20 million of those are unique, meaning they're not repetition, they're not just the same thing over and over again, where you're recovering basically bacteria. That's contaminants. But about 20 million unique base pair strings like you have the 365, 342. But keep in mind that the whole genome of us, of chimps, of gorillas, is right around 3 billion base pairs, 3 billion. And each billion is 1,000 million. So it's a lot. And it's expensive to do a whole genome, especially the whole genome of something long dead that's been, degraded very seriously. Again, it's doable, but it's expensive. Keep that in mind. So, what we are, so that you can understand the basics of it, as I said, is how DNA is passed to offspring. You have the offspring, a cell. When you are being created, you start as one cell. All of us do, one cell. And that cell is created when our mothers and our fathers contribute 23 chromosomes each to make the 46 chromosomes in each of our cells. And the nucleus of each of our cells in the nucleus is 46 chromosomes, and those 46 chromosomes contain those 3 billion base pairs. So you have the mitochondrial DNA floating outside the nucleus in the cytoplasm here, and you have anywhere from hundreds to thousands of these, and these are just little engines of making energy. That is what they do. But they are only 16,569 base pairs long. There's only 16,569 base pairs in every one of those hundreds and thousands of mitochondria in every cell that you have, in every cell in your body. All right? In incredible numbers, incredible miniaturization, but this is how it works. So the mitochondrial DNA is found in cell mitochondria and contains genetic material only from the mother. So your mother contributes the egg, and so it has the mitochondrial DNA in it. And your mother also contributes her 23 chromosomes into the nucleus, and your father contributes his 23 chromosomes with a tail attached to him, and that's all. So he doesn't bring any mitochondria in. So as we sit here, we have the mitochondria of our mothers, our grandmothers, our great-grandmothers, our great-great-grandmothers, and right back as far as you can go. That's our mitochondrial DNA. Now this is important to understand. It doesn't change very often. There are very few mutations in mitochondrial DNA. It's very, very heavily conserved, because if something goes wrong in your mitochondrial DNA, if you add a couple of base pairs here to make it 16,571 or 72, you're going to die. You're not going to be born. You will not make it out of the chute because your mitochondria is misfunctioning. So every so often a mutation, a single mutation, can get in there and last. And that creates a new haplogroup among humans. But understand that mitochondria doesn't change often. Now with nuclear DNA, it's different. Nuclear DNA is found in the cell nucleus and contains genetic material from both parents, the 3 billion base pairs. Because it's 3 billion as opposed to 16,569, 3 billion, there's plenty of room for mistakes there. There's plenty of room for mutations to occur and last. Particularly since most of our nuclear DNA is what's called junk DNA. It doesn't even have a function that we understand. Our bodies function on about 3% of that 3 billion, or about 90 million base pairs are the thing, genes are the ones, base pairs are the ones that combine into the genes that actually work. It's really amazing. So, understand that mitochondria doesn't change. That's the takeaway, because we're going to talk about that now. Human mitochondrial DNA is one of the best understood parts of human biology because it's 16,569 base pairs, and it's pretty easy to get to the end of that rope if you have a lot of time and effort, a lot of time and equipment and the desire to do so. So we know just about everything there is to know about mitochondrial DNA. And this is how it's broken up, and that doesn't really matter. Just understand that it's very well understood. And it stays the same. It changes very little over time. The mitochondrial DNA of every human can be found in one and only one of 33 haplogroups. Other lists contain more subgroups, but these 33 are widely used and accepted. Now, the interesting thing about this is each of us in this room belong to one of these 33 haplogroups. But I can belong to yours and you can belong to mine. We don't have to be related at all. We just have to belong to the same haplogroup. And what does that mean, haplogroup? It means that I and you have a distinctive set of mutations that fit our group and only our group. And there aren't that many because there aren't that many combinations of mutations and defects in our mitochondria. The most we carry is 120 mutations, 120 defects, 120 differences. In all 16,569, the oldest human beings, the oldest of us, have 120 of these defects. Everybody else has less because everybody else is newer on the planet. As we sit here in this room today, we're going to have in the range of 50, 60, 70, maybe some of us have 80. The oldest of us are black Africans who live in South Africa that have been found. The oldest of us, the ones 200,000 years old. Remember, our DNA package as it exists today doesn't begin on Earth until about 200,000 years ago. And then it just sort of appears. And here we are. So in those 200,000 years, our mitochondrial genome, those 16,569 base pairs, have collected 120 differences. Important to understand. In 200,000 years, we've collected 120 differences. All right? This is what they look like when you lay them out. Now let's imagine, if we will here, that we have 16,569 laying up against this wall here, these vertical red lines that you see here, 16,569. And as you see in this graphic here, most of them for all 33 haplogroups are the same. No changes, no changes. Most of it looks like that. But when you get a change, this is what you see. The computer marks it for you. Now this happens to be, it just happens to be, human mitochondrial DNA genome from number 1,262 to 1,426. That is of the 16,569 base pairs. It's 164 base pairs long, and it has, among humans, one mutation. Now, the other two you see off to the side are for Neanderthal and Denisova, and there's no point in really getting to talk about them, but they have faults in the same way in the same area. But with humans, one difference. So we all know what Neanderthals are. You might know what Denisovans are. You might not know what Denisovans are, but they're a new type of pre-human-like Neanderthals, but older. Okay? So, in that 164, one for humans. But with the Starchild, the reason we picked that is because we recovered four of the Starchild's mitochondrial DNA fragments. 4 fragments of its 16,000, or of our 16,569, however many it has, but 4 mitochondrial DNA fragments. One of which, the smallest of which is this one. From 1,262 to 1,426, the Starchild has 17 differences. 17 differences where we have only one. 17 where we have only one. Neanderthals have one at the same place. Denisova has one at the same place. Starchild has 17. Of the 4 fragments, when you combine them, they add up to 1,583 base pairs out of the 16,569. That's 9.5%. It's almost 10%. We have almost 10% of the whole mitochondrial genome. That collectively, those 4 fragments show 93 mutations at 10%. Now remember that the oldest of us have 120 only. 120. And you see it right there. The human has 120. Neanderthals, we're 200,000 years old. Neanderthals are 300,000 years old. 300,000 years old. They've collected 200. They have approximately 200. So they've got 80 more than us in 100,000 years. Sort of makes sense. The Denisova, the new pre-human, has 385. So it's significantly older than Neanderthals, probably 600,000 years ago, maybe 500,000 years ago, somewhere in there. But Denisova is clearly an older species than Neanderthal because it has more deformity, more change in its mitochondrial DNA. And chimps have 1,500. Look at chimps have 1,500. Now, chimps have been around for about 20 million years. 20 million years. In 20 million years, they've accumulated 1,500. So, the Starchild is between 800 and 1,000. What does that tell us about the Starchild? its heritage, its genetic heritage is in the range of 10 million years. We're 200,000 and it's in the range of 10 million years. Now, if you were a species with a history of 10 million years, do you think you can figure out how to fly in space? Do you figure you can figure out how to beat the speed of light? You think in 10 million years you could accomplish some amazing things that Greys obviously have done? Yes, we could. But I don't know that we're going to get those 10 million years at the rate we're going. We'd be lucky to get 10 more sometimes. But you see what I mean? The Starchild is not human. And this is just one aspect of all the things that we have. And I'm putting this out to you because it's simple, it's easy to understand, and it's clear, and it's obvious. Again, the morons can get it, but the PhDs, too much trouble. Don't bother me with the facts. The Starchild Skull can and will make history as big as history can be made. It will be the equivalent of landing on the moon. It can and will prove that alien life existed at least once 900 years ago. Because when we carbon dated it, we found that it died 900 years ago. 900 years ago. So at least once, an alien walked on the earth, lived here, died here, and was buried here. At least once. But that makes it obvious, I think, to me and to a lot of other people, that it's an ongoing thing, and it has been for 900 years and many years before that, and it will be many years into the future. Thank you very much. And again, if you want to learn a lot more detail about this, that's how you do it. Starchild Skull Essentials, easy to get, cheap, and full of information. Yes, ma'am?
Yeah, the two skeletons that the young girl found in the cave, were they both adults, or was the Starchild an adult and the other human was...
The human was an adult. She was a female, about between 30 and 40 years old, from the wear on her teeth. And the Starchild was an adult as well, but it was about 4 feet tall. The other one was about 5 feet tall.
Oh.
The human is about 5 feet tall, very standard height for Mexicans of today. And the Starchild was, the girl said, noticeably smaller, so we peg it at around 4 feet tall, which is about the size of most descriptions of gray aliens.
They must have known each other.
Yes, they would have known each other very well because she was willing to bring its dead body into the cave and bury it and then lay down beside it, wrap its hand around her own arm and kill herself. She committed suicide for it. So it's a very dramatic scenario when you look at it.
How did they know she killed herself?
Well, she was laying there dead beside it, so even if she just starved herself, but it's more likely that she cut her wrist or cut her jugular vein or did something. But the question is, why did she feel compelled to bury it, put the hand out, and then why did she feel compelled to die with it?
Maybe she loved it.
She could have loved it. She could have, or there could have been some other reason, or maybe she was protecting other people who would come to harm if it was found that this being was dead. And that's a possibility. Yes?
Yeah, we're talking about the skull and cranium. Any other bones recovered from
No
this?
postcranial bones at all, except for that piece of maxilla that was detached, but that's also a cranial bone. No, she just, all these are long stories you can find out in books that I've written about it, or on the website, or whatever. In lectures, you can't begin to cover 15 years of the story. But no, that she got this, she was lucky to get the skulls, frankly. Very lucky to get the skulls. Yes?
Were there any teeth? There were no teeth?
Yes, there were teeth. Yes, there were 2 teeth in the upper part of the maxilla that were recovered. One was given over to testing and wasted, and the other one still exists. We have 1 tooth left. And we have the crowns that are up in the bone. We have those as well.
Have you done analysis of the wear of the teeth?
Yes, you missed that part. You came in late. But yes, those are adult teeth. They were worn to adult length. Yes?
What if it was vice versa? What if the human died and brought her down?
Well, the alien couldn't have covered itself with dirt and done all that and stuck its hand out, I don't think. You know, maybe, but yes?
I came in late as well. I see that the time frame seems to be a lot longer for the chimpanzee. How come they haven't done anything today?
Well, that's a good question because they stay the same. You missed the first lecture earlier today when I was talking about the development of life on Earth. And basically, what you think is evolution, you think Darwinian evolution works and all here on Earth, it doesn't really at all. Their species come and they stay here and they make very minor changes in the way they are, like Darwin's finches or the tortoises that he found on Galapagos Island. But there's no such thing as transformation from one species into another. Evolution doesn't really work like that. They say that it does, and they insist that it does, but the evidence is simply not there. So chimps come in as chimps, and they will go out as chimps, and they're not going to become something other than chimps. They are chimps. And that they are a species here for that purpose, whatever that purpose is, just as we're here for our purpose, whatever that purpose is. Yes?
What's your new work going to be?
My new work is going to be mostly on the intervention theory that was in the earlier lecture, and I know you were here for that. The Starchild is sort of being taken over now by other people to do the lead role because I've been having some health issues and I've been having to deal with those. But it's in good hands, and it's in the hands of people that are really working very hard to work out ways to get the funding that we need through internet campaigns like Indiegogo and you know, things like that to try to get the majority of people out there to chip in a little bit of money and maybe give us the 3 to 5 million that we need. And it's a lot of money, 3 to 5 million, but that's actually as cut rate as we can do it, given what has to be done. To do the Neanderthal was like 20 or 30 million over the course of 6 or 7 years, but to do the Nisaba, to get its genome, because they wanted to do it, it was just a few $1 million, and it was done in 9 months, I think. So we can do what they can do if somebody puts the money in their hands. It isn't rocket science, as they say, you know, it isn't rocket surgery, I'm sorry, it isn't rocket surgery. It's doable, all we really need is money. It comes down to that, and we can't access mainstream money, like I said earlier, because they work very hard to keep it away from people like us. Any other questions?
Oh, I just wanted to say, the teeth that were up underneath the gum, that were unformed teeth,
Yeah.
maybe it was capable, when it lost teeth, of replacing its teeth.
That's exactly what we think. We think that it probably had a lifespan of hundreds of years, maybe thousands of years. And so when its teeth would wear down, it, like a shark, just like a shark, it could replace them with new teeth. And because there doesn't seem to be much reason otherwise to have that ability to grow new teeth to that extent.
Maybe if it can grow new teeth, it can grow a new heart, it can grow a new liver, it can grow a new arm.
We don't know. It could happen. Like what would have killed it? You know, like War of the Worlds. Maybe some pathogen here on Earth took it out. We don't know. Personally, I mean, if you ask me, I think it was a pilot of a ship that somehow got crashed here, like we talked about the crashes earlier, and it was just a living being, and this female human took care of it to a certain point and it died, and something convinced her that she had to get its body out in the middle of nowhere and hide its body very well, and that she better go ahead and kill herself for doing that for whatever reason. It's a very dramatic and possibly romantic story, but whatever it is, it has had it's going to have quite an impact on the future as soon as we can get enough people to understand the importance of the Starchild Skull.
Lloyd, is there any, from the teeth, is there any idea of whether it may have been vegetarian or meat eater?
May have been what?
Vegetarian or meat eater or what?
It seemed to eat everything that the woman ate. When you check its biochemistry, it seems to have been eating the same things. I can say this though, the roof of its mouth was not arched like ours, and this is another aspect of the speaking, but I can't jam all there is into an hour or 90-minute lecture like this. but the roof of its mouth was flat, okay, flat. And its mouth was the size of an infant.
Right.
So if it had a tongue, and we assume that it did, its tongue was like the thickness of cardboard because the roof of our arch is roofed to hold our tongue. So if it had a tongue like a piece of cardboard, it was a food flipper. It was just for flipping food, and it seemed to eat because its teeth had wear and tear on them. So it would just be flipping the food back down the little bitty tube that would be its swallowing, its esophagus, and that would be pretty much the extent of it.
I just wonder what they ate.
Again, its biochemistry indicates that it was eating the same things that she was eating. No fish, because they were in the middle of nowhere. Tubers, certain tubers and root vegetables and things like that in the area, corn. And that would explain some of the chipping and grit marks on the teeth, because the corn would have been ground by a stone pestle at that time, 900 years ago. So, any others? That should be about it.
Well, Lloyd, we really appreciate you coming all the way to Presidio, and it's been a pleasure having you here. I've enjoyed listening to the lectures. And, you can also watch the videos on this website as well. I think you were nice enough to let us link, and so
Absolutely.
you can go to ufoborderzone.com. It's on the back of your t-shirt. And if you haven't got a t-shirt, get one. And then, of course, we have the t-shirts over here.
That's true. You've got some Starchild t-shirts over there if you're interested in that. Pretty cool to have, and let everybody know that you're aware of it. You think they're cool? I think it's cool.
They're pretty cool t-shirts.
They are very cool t-shirts.
What? All monies are going to the scientific research. Please.
Yeah.
Also, I'd like to thank the Youngs for being here.
Thank you for having us.
They're practically neighbors. It's El Paso. You know, we go to El Paso to watch a movie, and they come to Presidio to catch a UFO conference. So I guess it's a pretty good trade-off. But anyway, it's been a pleasure having you both here. Lloyd, we hope you can come back. And,
Thank you very much.
I'm glad that you're doing well.
Listen, I just hope I stay above the lawn and can come back.
I hear you. We have a few other orders of business that's going to kind of cut into your supper break. I guess we're arriving on that hour. We actually have some great entertainment. The Rocky Top Alien Breeding Experiment is here from Terlingua. And they took in the lecture and everything, so they're inspired. They drink the water outside. Also, our testing table out there to try out the Koyami rocket fuel is out there called Sahol. And if you've never had that, it is an experience. I've experienced it very much in my past days. But anyway, pretty good stuff. And it's made locally in Koyami and bottled in Aldama. We have a lot of our friends from Aldama here, the great state of Chihuahua. And if you want to talk about going to Copper Canyon or any of these things, Mr. Rivera is here, and he works for that department. And boy, if he could take home a few scalps in his pocket, he'd love that. So anyway, I'd like to call up Noe, and we have Chris here, and I don't want to mess up the name. It's go ahead.
Yeah, just a brief announcement before we take a break.